Okay, I think we're all in here, and we can get started because this is the last session between us and lunch. So I want to introduce Jody Hunt from CyberArk, and coming to talk to us about machine identity as we start moving into the microservices age. So Jody, all yours.
Y'all hear me? Oh, wow, yeah. I guess you can hear me. All right, so machine identity in the cloud and microservices age. I'm Jody, I'm with CyberArk. I was with a company called Conjure that got acquired by CyberArk about a month ago. So we were a little startup focused on this space. So I like to kind of set the context first is what's going on in application architectures. As we move from the legacy sort of monolithic approach to applications to the virtualized service-oriented architectures, and now into the container and microservice age, what we're seeing is just a vast proliferation of the number of things under management, right? And that's causing some trouble. It's causing some trouble from an operational perspective. It's also causing some trouble from a security perspective because now we've got a lot more entities that may need access to secrets and passwords and these kinds of things. And we can't use service accounts like we used to because service accounts are very long-lived. And when you've got a microservice that only lives a few hundred milliseconds, you can't be provisioning and deprovisioning those identities using the same methods that you used to use. So this is the fundamental problem that's facing security in this space. And this is something that we've been very focused on. So everybody's probably heard treat servers like cattle, not pets, right? So a cow is pretty long-lived. It's pretty substantial. I would say a cow is more on the left. And as we get into containers, they're lab rats. And as we get into microservices, they're Kleenex. They're highly disposable. So we can't invest a lot in the provisioning of identities for these things, and yet they need to be identified. They need to be authenticated. We need to be able to authorize their access. So how do we do that? Well, a veritable cornucopia of automation. Everybody's using something. There's a usual cast of characters, but the combination is almost unique among every organization we talk to. So Ansible's on the rise for some reason. I think it's Red Hat. So Ansible and OpenShift, we're seeing a whole lot more, whereas it used to be the more venerable Puppet and Chef for automation. Jenkins, almost everybody uses, unless they're a Microsoft shop, and they're using TeamCity. Test automation, a lot of tools there. A lot of folks getting into container orchestration and using Mesosphere, Kubernetes, OpenShift for that. So this is a response to the need to automate or to manage these environments because people can't keep up. There's too many things going on. They're coming and going too fast. And so you have to have these robots that are doing your work. But realize that these robots are doing what your privileged system administrators used to do. They are privileged access in your actors in your network. And so you've got robots as your administrators now. And while they may not bring down the downfall of humanity, bad things can happen if you don't have control of your robots. And it's not enough to have control. You need to prove you have control, right, for audit and compliance purposes. So this is the problem that we're trying to solve. This is what we call the problem of machine identity. Because it's a new threat vector. It is a broadening of the attack surface. And every attack follows the same pattern, a compromise of credentials, and then the use of those credentials to move laterally in the network, start exfiltrating data, taking over more and more of the network. So if we don't secure the privileged users, which are now automated entities, bad things can happen. And this is what we're in the business of preventing. So how do we do that? Well, first off, let's look at the space because what we're talking about is the scale of the cloud and the speed of DevOps. And probably most of the folks here have heard of DevOps, and probably most of the folks here have now heard of DevSecOps, where we're adding security to these DevOps workflows. But very few companies have really focused on this, and this is, every presentation somewhere has to have a Gartner quote, right? So here's the de rigueur Gartner quote. But the point is not a lot of people have really started thinking about this yet. Most of the automation tools, if they have some sort of security, it's added onto it. It wasn't built with that in mind. So if you're using Chef's encrypted data bags or EAML and Puppet, these various other things, they're add-ons. And so we'll look at the challenges there. But the point is that you've got these entities that need to be secured, and few people are really looking at it. So an explosion of short-lived entities, a lot of privilege automation tools that are doing the work that used to be done by sysadmins, and security that needs to work at the scale of the cloud and the speed of DevOps. That's the challenge that we're dealing with. So here's some practices that we espouse. First, ephemeral secrets. I just like the word ephemeral. And I've got a slide on each of these, and then I've got a summary slide at the end that repeats these. So we want to get secrets out of source code. Second, no security islands. We don't want this to be discontiguous with our established practices and procedures, so we don't want islands of security. Third, embrace machine identity. You need to authenticate your non-human actors and authorize them for access using zero trust, least privilege, role-based access control, all the good things that you know about security. You need to apply those to these non-human actors as well. Security is code. This is a big part of DevOps. Infrastructure is code. Everything is code. So what does that mean? Well, we want to define what we want and have the tools implement it. I'll talk about that in just a second. And then security as a user experience. For most people, security is not a good user experience. We want a good user experience. And so what does that mean? How do we do that? So first, ephemeral secrets. No embedded passwords. Does anybody still have applications that embed passwords? Hopefully nobody says yes. Because that's bad. You don't want that. That's an easy place for people to go and start compromising your security. It also makes your applications brittle because you can't rotate a password if you have to go rebuild the application to do it. So you want the secrets out of your source code. You want it into some kind of encrypted vault, and whatever you're using. That's a good first step. And then you want to be able to rotate those passwords so if the credential gets compromised, it's not usable very much. So hopefully that's just table stakes and everybody's already on that. Second, no security islands. So we want to be able to delegate trust to this new space. So recognizing that we've got a new problem that's going to require new solutions and a lot of automation, we don't want that to be by itself operating in a discontinuous fashion with our established enterprise infrastructure or identity and access management and privilege access management solutions. So we need to be able to delegate trust. I use the term cloud security admin here. It may not be actually the cloud. It may just be the person over this DevOps automation space. So it could be on-prem as well. But the point is, the security solutions that are going to work for these short-lived non-human entities need to be contiguous with the other solutions that you have for the rest of your infrastructure and your people. You don't want them to be isolated. So we see people saying, well, why can't I just use AWS? And it's like, well, great, that's great for AWS. It doesn't work in Azure. You've got different principles, different identities, different everything. And the same with the security solutions that come with the tools. They work great for Chef, but what works for Chef is completely different approaches, different procedures and everything. So you get this balkanized security profile if you don't start thinking about this as an enterprise solution and making it contiguous with your established principles. So a bit of advice there. Now another thing, and this, actually that's the next slide. What I've depicted here is the need that here we're mostly working with applications and people and infrastructure. Over here now we're starting to deal with some of the automation represented by Puppet and Chef and the delegation of trust to those. So that's when we talk about machine identity, and that's the need for being able to extend the chain of trust from the privileged administrators to the less privileged administrators who may be only responsible for certain functions, and on to the applications and the automation themselves. So we need to be able to allow administrators to delegate trust to a Jenkins process that needs to fetch database passwords or needs SSH access to test servers. We need to know what that Jenkins process is, uniquely identify it so that we know it's the Jenkins process for this particular application and only give it access to the secrets that it needs using least privilege principles. But this is easier said than done because Jenkins can't remember its password. The fundamental problem in this space is these things can't remember their passwords. And that's why I've taken to using the, who here has not seen the movie The Bourne Identity? So yeah, everybody's seen that movie. How does Jason Bourne get his identity back? They fish the guy out of the water. He doesn't know who he is. How does he get his identity back? He has this thing in his leg. It says, go here, turn this in. Now he gets his passport back. He gets his identity. So we use the same kind of approach where we are using a way of bootstrapping identity where we've got enough confidence in that delegation of trust to establish these identities in a very dynamic fashion. I won't go into more implementation detail there, but the point is we can set up these processes. The administrators can create the clockwork, and then the clockwork could kick off and bootstrap identities and more or less function autonomously. And that's really where we want to get to when we start talking about user experience. So third, security as code. So this is where we're borrowing some ideas from automation. If you've worked with Puppet or Chef or some of these tools, you know that they're declarative in their approach, whereas older approaches were imperative. So they were very command-driven, very script-oriented. We know that those are brittle. We know that those don't scale very well, and they also don't transfer easily for knowledge and just general personnel rotation. So taking a page out of that, what we'd like to be able to do is describe our security model and then give it to the automation and to enforce it. And so this is something that we've really focused on, is how do you declare your security model in such a way that it's pretty stable, but that it supports this very dynamic environment of host enrollment, privilege grants, host retirement, and do that in such a way that you can delegate trust as needed. You know that those policies are in effect. You can audit against those policies. You can version manage those policies so that the security policy for an application is versioned right along with the source code. So that's what we mean by security as code, is the security model tracks the things that it's securing, that we can delegate the trust to those administrators or the developers or whoever it is that needs the trust, and delegate the trust to the hosts that need access to those. So if we've got an application, and that application needs access to a database password, that's captured in the security policy. And that application only has access to that database password and nothing else. And that's also enforced by the policy. So that's what we mean by security as code. The last bit is that it can be used for reconstructing your entire security profile. This is something that's very hard to do. Has anyone had any experience with a really messed up Active Directory implementation? This is a very common occurrence. The reason that gets so messy is because it's command-driven. You're using scripts to do that, and you don't have a policy that you can go back to and easily say, okay, here's what it should be, and here's how we put it into effect. That's what we're avoiding when we start taking this declarative approach. And what's cool about that is if you have these documents on record, you have them under version control, you can use them to reconstruct your entire security profile for DR purposes or bringing up new data centers or other things. So it's again, looking at security as code and all the goodness that has come using the same principles for automation and configuration management. So fifth, everybody get the numbering scheme? There's programmers, right? Security as a user experience. So this picture on the left, so I've been talking about DevOps for like 6-7 years now. And back in the day, this was the picture that resonated with everybody. This came from Damon Edwards' blog site, where the conflict was between developers who had adopted agile approaches to introducing change and recognized that all of this is business driven. We're not doing this just because we think it's cool or because it's fun or whatever. We're doing this because it's a business imperative. The Ubers and the Airbnbs of the world, everybody's sites, have shown that organizations can be very disruptive with little more than a clever business plan and some good software. And that's what every business is dealing with, is fighting this. And this is why we're trying to introduce change at such a rapid rate. So this started back with developers because they used to be the constraint. If anybody's read the Phoenix Project or the Goal and knows about the theory of constraints, the constraint was the development side, and they couldn't produce change reliably very quickly. They started adopting Agile, and so where the release cycle used to be every 6 months or 9 months, it started going down to like every 6 weeks. They could produce change every 6 weeks in response to business requirements. The constraint moved over to operations. They were not ready for that that pace of change. And so this is where the conflict used to be. Now, fast forward 5 years with automation and a lot of the DevOps principles that have been adopted, now this team is saying we can produce change reliably at scale and speed, and its security is saying, well, it needs to be secure. And you guys got to get on that. So that's where we are today, is how do we make security the good user experience? So I literally had this conversation with a fellow a couple of weeks ago where he put up a slide showing their current workflow for developers. And the developer checks out secrets from a vault, pastes them into a configuration file, submits a configuration file with the Jenkins build, and hopefully remembers to go clean that up. And so you're relying on so there's two things bad about that. One is the developer hates it. The developer, it just reinforces the developer's perception that security is an anchor. It's an impediment to their productivity. They could be doing a lot of other things, but now they got to do this stupid security protocol where they paste the secrets in, yada, yada. The other thing is you're relying on their discipline to clean up after themselves and not leave these secrets out in clear text somewhere. So it's really got two issues. So there's every time I say this, I say I'm going to go find who said this, but I think there's a lot of wisdom in this what I'm about to say. Make the right thing to do the easy thing to do. If you want compliance, make the right thing to do the easy thing to do. And so what we really want is for security to just happen and just be part of people's job, not something special that they have to do, as on the case on the left. So the good workflow, the happy workflow, is where the developer checks in the code, it triggers an automated Jenkins build. The Jenkins process is authenticated and authorized to fetch the secrets, pull those into the configuration file, and when that Jenkins process exits, those secrets disappear. That's the good thing. The developer is compliant. The developer isn't even involved, which is maybe the best possible scenario. It's invisible to their workflow. We can track what happens. We can audit the flow. We know we've authenticated the process. We know when it fetched it. We know what it was doing with it. If somebody were to compromise those principles or those privileges, we would know about it. And the secrets don't survive past the build. So when we say make secret a good user experience, it means integrating it into the workflow, making security, making compliance with the security policy the easy thing to do. That's what we mean there. So happily, I'm at my summary slide. So I'm just recapping here what I've just said. No security islands. Extend the chain of trust. Have continuity with your established policies and procedures. We're not reinventing the wheel here. We're not reinventing concepts. We're just applying them to this very new and dynamic space. To do that, we need security as code. We want automation to enforce our policy. We just want to author the policy and declare what we want, have the tools take care of enforcing it. Machine identity, this new challenge of bootstrapping identity because these things can't remember their passwords, and then using those identities to authenticate, authorize, apply role-based access control, zero trust, least privilege. Ephemeral secrets, get your secrets out of the source code. Start there. I think actually that was my first slide when we got into the details. So really, that's if you do nothing else, and if you take nothing else away from this presentation, start there. Get your secrets out of source code. And then making security a good user experience. Automate it, make it mostly invisible, and make it just part of people's day-to-day actions. So, any questions? I guess I have to surrender my mic now.
You're going to give up your mic, you're going to use that one now.
Check.
Thank you. So on slide offset 5, which was your last slide, you mentioned having the secrets be generated based on essentially Jenkins going and retrieving it based on its unique identity. Can you describe where those secrets are stored?
They're stored in an encrypted vault. You need to have that, and we like to say it's easy to encrypt something and store it. The fun part is how do you retrieve it? And how do you make that part of the workflow, and again, with the machine, bootstrapping the identity so that you can authenticate that in the first place. But yeah, it's in an encrypted vault. You want it encrypted on the wire. Everything's encrypted all the time except exactly when it's needed, and then it goes away because it's ephemeral. That's the goal, right? And the devil's in the details.
Got it. Thank you.
one over here and then one over there.
This is a little bit of an offset question. So we all know about the secret passwords living in the code repository as fundamental cleanup activity to do. So what is your initial thought to make it a business use case than an IT initiative or a security initiative? How do we get started on what you just presented?
Well, so it's a risk thing. So risk is probability times impact. So that's an easy way to express it. What are the chances that those secrets could be accessed? And if they are accessed, what's the potential negative impact? And if you start expressing it that way, I can't imagine any organization not wanting that. It's just they probably never thought about it before. I mean, I think it's just one of these things that, wow, we always did it that way. Now that's a problem. And there are documented cases where Vine, I think, you guys remember the Vine they were compromised by somebody going to their GitHub site and harvesting the secrets, and basically they appropriated the entire service and ran it from a laptop. And so there are cautionary tales out there that you can use to make the case. But if you want to take it down to some sort of mathematical kind of thing in terms of quantitative impact, risk is probability times risk is probability times impact, and that gives you the ability to say, if these secrets get stolen, this could happen. That makes the risk this high versus this high. So if you can reduce the probability that it's happened by taking them out, or reduce the impact by only putting, maybe you don't have really privileged secrets, maybe the impact isn't going to be that high, and you can use that sort of formula to assess.
So when you mentioned removing secrets out of source code, would you recommend using group certificates instead of secrets themselves?
Yeah, well, I mean, there's many ways to skin that cat. I mean, you can roll your own fetching and just have the developers write to an API that fetches secrets, and even if they're not strongly authenticated, just the fact that the secrets aren't in the source code is a good first step. But the implementation, that's really up to you. It's how do you what you'd really like to see is where the developers, again, you don't want to have a severely negative impact to the development process. And I think an API approach is a good one to start with. Even if it's not authenticated, at least it's dynamically being fetched. And if it's secured, then they can use that. So I don't know the details of what you proposed, so I can't really say if that would be a good way to do it or a bad way to do it. But as long as the value is not baked into the source code where it can be harvested and it's in a place where it can be rotated, that would be the goal.
Could you go into a little bit more detail on the bootstrap process? 'Cause like in that previous question where you're asked, where are the secrets? Are they in a vault? Okay,
Yeah.
Well, so then that vault is protected by some key, and so then how did you provide that key at that time? If it's not a human being actually doing it,
Yeah.
then you have this problem of like, where does that key come from?
Yeah, okay. So I'm going to try and do this verbally. This is normally where I look for a whiteboard or get my Mac and bring up some diagrams. So the idea is that you have this token that is issued and it's defined as part of the security policy. What we do is we group non-human entities separately from users. So we call these layers, hosts and layers. A host is a non-human identity, and a layer is a group of non-human identities. I think this came from AWS. But the concept, not the implementation. So we have this layer that we can give privileges to, and that's a role effectively, and any member of that layer will inherit those privileges. So we're defining that in the policy, and that's just structure, right? There's no host exists yet. We associate with that layer what we call a host factory, that is a service that will issue tokens that can be redeemed for identities in that layer. So we've established the privileges on the layer, and we've established a thing that can issue a token that can be redeemed for an identity in that layer. And that identity is only good for the permissions that were given to the layer. So we've constrained this process first by the policy, and using a least privilege approach, it's only got privileges. Wherever the hosts come from, they've only got privileges per the layer. Now we've got this token that we can cache somewhere. We can hide it under a rock effectively. We can put it in a CloudFormation template. We can put it in an S3 bucket where we can rotate it. So we can also revoke this token. We can set an expiration date on this token. We can cite or restrict this token, so it's only good if redeemed from certain IP addresses. But that cached token can then be picked up by a Jenkins process or an application and redeemed with the service to get its identity. And once that identity is granted, we know who it is, we know what it's capable of, because it's very closely, it's dictated by the policy. So I don't know if that makes sense, but does that basically, we hide a coupon under a rock, and we say, look, you can use that coupon and go get a key to the house. And as long as we don't broadcast the fact that the coupon's under the rock, it's pretty secure. But then we have second and third factor controls in expiry dates, in the policy definition, and in the CIDR restrictions.
Cool. So Jody, thank you very much for your presentation. And that brings us to the end of this track. So I think the next on the schedule is lunch. So thank you all for coming.